In this video, we're going to learn about the change of base formula. So if you ever want to change the base of a logarithm to a different base, you can do that by taking the log base any number you'd like as long as it's not 1 of m divided by log base c of the given base already. Now, the reason why this works is if you were to take log base b of m and multiply it by 1, in this case 1 is represented by log base c of b over log base c of b, when multiplying together you'll get log base b of m times log base c of b. Now we have two things being multiplied. We went over a logarithmic rule in the last two lessons that would equal log base c of b to the power of log base b of m. All over log base c of b. The question now becomes is how does b to the log base b of m simplify? Now, if a logarithm is equal to the power you raise the base to get the inside number, it would make sense that log base b of m is the power we raise b to get m. So b to the log base b of m should just be m, since the log represents the power you would raise b to get that. So I can rewrite my expression as log base c of m divided by log base base c of b. And that's where that formula comes from. Now let's put this into practice. One thing I'm noticing over here with log base 81 of 27 is that both 81 and 27 are powers of 3. So using the change of base formula, I can rewrite this to be log base 3 of 27 divided by log base 3 of 81. Now, 27 is also known as 3 to the third, and 81 is known as 3 to the fourth. So this can be simplified as 3, since 3 is the power you raise 3 to get 27, over 4, since 4 is the power you raise 3 to get 81. So you just get 3/4. So if I see log base 8 of 32, I can think of that as log base 2 of 32 divided by log base 2 of 8. And the order always for these numbers is the inside number goes to your numerator while the base goes to your denominator. Now, I know that 32 is 2 to the 5th and 8 is 2 to the 3rd. So this just simplifies to 5 over 3. Now let's say that pattern doesn't hold up the same way it did on the left here, where you don't always see powers of one number in your base and in your inside number. Well, we can still use this, and when we can implement a calculator to help us find that number. Now, since the base can be anything, let's say that base is the common log, just log, which is log base 10. I can rewrite this expression as log of that inside number, 36, divided by log of the base, 5. And that decimal I get is what log base 5 of 36 is. So log of 36 divided by log of 5 is 2.2266. So that's the power, if you think about it, that you would raise 5 to get 36. That makes sense because 36 is bigger than 25, which would be 5 squared, and definitely less than 125, which would be 5 cubed. So it should be some number between 2 and 3. Here I could use that same logic to kind of guess where this would be. I know that 4 squared is 16, and 4 cubed is 64. So log base 4 of 18 should be between 2 and 3, because 4 squared is less than 18, and 4 cubed is more than 18. So if I rewrite this as log of 18 divided by log of 4, I get the decimal 2.08496. Which it makes sense that it's closer to 2, since 18 is very close to 16. But that would be the power you would raise 4 to. So 4 to the 2.08496 is approximately 18. Now, since I'm rounding this number, that's why I'm putting this approximately symbol. Because if I actually did put 4 to the power of 2.08496, it wouldn't always be exactly 18, but that's pretty darn close. And the more decimal places I use from that decimal from before, the closer I'll get. But just to show you that it does work, if I did log of 18 divided by log of 4, if I don't round that number into 4 to that answer given before, it gives me exactly 18. Now let's look at log base 4 of 32, which I'm going to write as log of the square root of 32 divided by the log of 4. So log of the square root of 32 divided by the log of 4 gives me 1.25, which that's not even a repeat like a long decimal. So this means that this is equal to 1.25, not even approximately. And 1.25 is the fraction 5/4. So that means we could raise 4 to the 5/4 power to get the decimal that is the square root of 32. Now, this same technique can be used in the problems like you saw before. Another way I could also evaluate this log is to put in log of 27 divided by log of 81. And 3/4 is 0.75, and I would get 0.75. And that is how you use the change of base formula.